let's continue worksheet 10B for the T-beam. In the previous portion, we already found out where is the centroid, and that we can be able to locate the neutral axis. And we also set up the table to find out the location of the centroid and also the area moment of inertia of the whole cross section I. The I is for the whole cross section, nothing to do with the outward areas. Now we move on to find out the Q, the first moment of outward areas. That's what we touch on for the T VQ over IT. Okay, T equal to VQ over IT. So find out Q. So two Q that we need to find out, that Q at the neutral axis and also Q at point B. So let's first start with the Q at the neutral axis. Q at the neutral axis. So what do we have here? Again, it only one shape in there, so it equal to y bar a apostrophe, and that y bar determined from the centroid of the from the neutral axis or the centroid of the whole cross section to the centroid of the outward areas. So there are two ways that you can do, and they will have the same answer. Okay, so in this case, the Q neutral axis, you can find out from here to the top outermost fiber. Then you can break it down into two shapes. The first shape is the 2 by 6, and the second shape is that smaller portion in here. That's what you can find out the Q&A. The other way that you can find out is, okay, I forget about the top bottom, because neutral axis, it can be go to the top most fiber or go to the below the bottom. So Q&A, it will be the same if instead of that, I can find out these areas. Okay, that is also the outwards area. So either way, you get the same answer. And here I try both. Okay, for the blue one, as you can see, it equal to y bar from neutral axis to that point. So it equal to 5 total. So divide by half that blue areas from the red point there, which is the neutral axis, to that the total height is 5 inches, because that is y bar. So it will be half of that. So you have 5 over 2 time the areas, 2 inches times 5 inches. So what do we have here? It equal to 2.5 times 2 times 5, so it's 25 inch cube. You also be able to find out, like I say, the other equation. Let me erase that. That is the first way that I can find out. The second, I want to find out the green dash in there, and also the red dash in here. That to the top outermost fiber. So that Q&A, let me put or, and you will see that it's the same. Q&A in that case equal to sum, because the two areas, right? The red and the green. So it will be y bar a apostrophe. So let's talk about the red. So it equal to y bar. It's here 3 to 2. So you 3, as you see there, and 2 is the thickness. So to the centroid of that red dot, to the black dot in there. So you can see that is 3 inches minus 1 inches, that is y bar, time the areas. So that is 2 times 6 inches for the flange, plus for the green, shaded green in there, it equal to 3 minus 2. So as you can see, 1, the area is 1. So from the red to the green dot here, as you can see, it will be equal to only half, so it will be equal to 1/2 inches time what is the area 2 times 1. So with that, you also find out this is 25 inches cube, and it should be the same answer as you can see there. So you use either the from the neutral axis, for the neutral axis, the Q, the first moment of outward areas at the neutral axis, you can do that to the top or to the bottom for the outward areas. And both, if you do correctly, you will get the same answer. In this case, 25 inch cube. If you don't get the correct answer, then go back to check something wrong. And that for the quiz, for the exam, and as you can see, if you have time, so go back to check that, make sure you do it correct Q by do both way and check, they should get the same answer. And for equation IT, we also need to find out T, and T at the neutral axis. In that case, as you can see, go through neutral axis, the T, the width of the beam at the neutral axis, actually 2 inches. 2 inches. Okay, so that's what we have for the neutral axis. Similarly, we can go ahead to find out for the Q at point B. Okay, Q at point B, and that's very similar to what we do in Q at point B. Do in worksheet 10A. Point B is equal to, again, A apostrophe, and this is only one areas, and one way that go to top in there. So B, as you can see, the it will be from the centroid to centroid of the whole cross section, so neutral axis to the centroid of the red, as you can see. So it will be equal to 3 inches minus 1, right? Let's see, minus 2 inches over 2, so easy for you to follow later on. That is the y bar, and then we time the areas, that is 2 inches times 6 inches, and with that one we will get it 24 inches cube. And the T, the thickness at point B, as you can see, B is the intersection at the web and flange. So if you just jump B a little bit up, so the thickness it become the yes, 6 inches. If we just go a little bit down, then it will be 2 inches with the thickness of the web. So as you can see at point B, there is a discontinuity in the distribution that I will show later on. And have 2 thickness, as you can see there. So TB is equal to 2 inches. If it go down, so let's put it go down, B down, right? 2 inches, as you can see. Or, and TB, if we're talking about the B just up, it belongs to the flange, then the T equal to 6 inches. So T, it belongs to the web, it will be 2 belong to the web, because that is the intersection. Just like you are in the intersection of the road, like Alico Road and Ben Hill Griffin intersection. So you can say, okay, if you just lean to one road, you can I'm on the Ben Hill Griffin. If you, either way, I can on the Alico Road, because at the intersection. So that same it in here and bottom. So when you have all of that, you can go ahead to find out the tau. So tau for the neutral axis, V Q and A, right, over I T and A and A. So we have everything. So plug in we have that equal to 50. Thank you. NA 25 divided by I 136 in 4. TNA equal to 2. So from that we have tau at the neutral axis, and that get the maximum for sure. It will be 4.6 euro KSI maximum in this case, because that we get the maximum Q, and that is the first answer we have. And the tau for point B at the thickness depends on that B is linked to the flange or linked to the web. So we have it TB if it to the web, then we have that is 50 Q for B 24 and chain I for the whole cross section and chain 136. But for T, that is for the web, so it's 2. So from that we can get equal to this one is 1 point, should be 4.41 KSI. So if that is the first TB, as you can see in the section, the answer. And then we can also find out what is tau transverse shear stress at point B, but it belongs to flange. It equal to 50, same, 24, the same. Only the thickness are not the same. 136. And in this case, 6 inches. So from that, we will have 4.41 KSI. Nope, that one is less. By that, so it equal to 1.47 KSI. So that is part A of the T box. We want to also find out part B, which is the distribution of tau. So B tau distribution, and everyone know that is should be a parabolic. So let the same put the side of the cross section, and the neutral axis is not in the center anymore. That the whole thing is 8, but it lean to the top. That here is the neutral axis. And point B at the web flange intersection 2, so it will be point B here. You can see that the whole thing is 8 inches. Whole thing there, 8 inches. To neutral axis 5. Point B 1 inches, 2 inches. So totally 8 inches. So what it look like at the neutral axis, it will be 4.60. 4.60. From here, go to 4.60. 4.60 KSI. Okay. And then B, there are two. If it belongs to the web, so it is 4.41. It belongs to the flange. It's 1.7. So we can say that let extend that here 1.7. So about that, and then that is 1.47. And if belong to the web, so it's about 4.41 KSI. So how can we draw it? Parabolic. So it will be here, parabolic from there to there, parabolic. And then it got the discontinuity in the shear stress. And again, it continue with the parabolic in there. And for the next one, the lower part is no flange, so it will be continuous for this, and it's still parabolic. So that should be the distribution for the bottom part, and 0 at the edge, 0 at the edge. So that what is the distribution for transverse stress in the T-box. So with that, we're done for worksheet 10B.